Ground floor. Accurately pricing the ground floor is complex, but the NHE Plus makes this task simple while still providing all the options that may be needed. These options include block and beam, timber joist, and perhaps the most common, a concrete slab. We also have multiple options on the type of wall, including single, double, trench blocks double wall, trench block on belly, all of which provide the ability to specify the combination of brick or block that will be used. Plus, there are insulating concrete formwork options. The wastage allowance for the ground floor section is here. This is the percentage of wastage that is being added to the materials. This is a yellow box, so we can adjust it if required. Over here we have a pictorial reference to the type of walls that are selected for the external and internal ground floor walls. At a glance, we can see what the costs are based on. We'll now look at how these are adjusted in the external walls and internal walls sections of this movie. External walls. First, enter the depth of topsoil to be removed into the red box. We can click the red question mark and open the interactive diagram if a visual reference is required. Now enter the length of the external wall's outer leaf into the red box. By default, a double wall is selected, and the NHE Plus automatically calculates the length of the internal leaf for us. This thumbnail picture has 4 small red arrows pointing towards the red and yellow boxes. This means that this thumbnail can be used to check and enter the information into these boxes. Click the thumbnail, it opens the wizard. First we select the type of wall. Use the self-explanatory pictures to choose how the ground floor walls will be constructed. Just click on the one that's required. There are options for a single wall, a cavity wall that's filled with a lean mix up to ground level, trench blocks double wall, and if we're using insulated concrete formwork, we can select a single wall or ICF with an outer skin. We'll select the double wall option, but whichever option we select, we're provided with the same sequence of forms that enables us to fine-tune the details. They all follow the same format. OK, in this form we can see the length of the external leaf that we've entered and the internal leaf that's been automatically calculated for us. If we'd chosen a single wall, the internal leaf yellow box would be empty. We can view how the programme has calculated the internal leaf by clicking the info icon. We'll click Next. Here we can see how the programme is working out the quantity of materials we'll need for the walls. All of this can be fine-tuned if required. Let's start with the yellow drop-down boxes. OK, so this is the height from foundation to DPC. All of the height options in this drop-down menu are courseable, which means they're divisible by the sizes of standard bricks and blocks inclusive of the joint. With the current setting, we can see the number of courses of bricks, blocks and regrades that these walls will be made up of. Look, if we adjust the height from foundation to DPC, the number of courses in the outer and inner leaf will automatically adjust so they can fit. We can also change the height of the facing brick from the DPC. Again, the measurements in the drop-down are also courseable. If we change it, the number of courses adjusts. We can alter the type of wall we will be constructing by using the pictures at the top of the form. At the moment, we're set on brick and block, but we also have options for all brick or all block. If we were building in London, for example, it may be that building control insists we have all bricks. To select the all brick option, just click on the picture. We can see that we now have no block courses allowed. The information has automatically adjusted and shows the quantity of regrade and facing brick courses. If engineering bricks are needed instead of regrades, we can just select the appropriate material in the bricks below DPC description on the pricing sheet. We'll look at this shortly. If we require all blocks, which for example is often the preferred method in Scotland, again just click the picture. Automatically the number of block courses is shown. There is some blue text. This is letting us know that the height of the foundation to DPC is not courseable for all blocks. So the programme has rounded the course up to the next full course. This means we will not have the height for a full block on one of the courses, and to achieve the selected height, one of the courses will have to have the blocks cut. If this is what we intend, then leave the setting as it is. If it isn't, we'll need to adjust the height of foundation to DPC so that complete blocks can fit. The final option is block on belly. Click here to view the PDF that explains how to adjust the settings in this wizard to construct a wall of this type. The default measurements for the brick and block can be viewed by clicking on the brick or blocks shown here. These are standard sizes, but if we're using an older brick or if a new brick comes onto the market, they can be changed. We can also change the joint size on both the brick and block too. It's important to remember that if the default brick and block size settings are adjusted, the course multiples are likely to be affected, so the heights in the yellow drop-down boxes may need fine-tuning. Or, if the sizes we have selected for the bricks and blocks mean that the bricks and blocks are no longer divisible by the default course multiples, we can use either of these buttons here to adjust the course multiples to ensure that complete bricks and blocks are allowed for. Another nice feature is this. If we hover over any of these eye icons on the outer or inner leaf, we can see the quantity of bricks or blocks we'll need. So in this example, I can see the number of rows of facing bricks, and this is the total number of facing bricks needed to complete them. Okay, we have gone into a lot of detail about all the things that we can do with the external walls. If required, the built-in help can be referred to. Additional written explanations with pictorial examples can be found by clicking any of the blue info icons. When this form is set to the requirements of the job, click Enter Details, and the information will be entered onto the pricing sheet. See, the details go into the boxes I pointed out earlier. Internal walls. Now we enter the lengths of any internal load-bearing single or double leaf walls. As with the external walls, we can enter the measurements directly into the red boxes, or we can use the relevant thumbnail picture to make use of all the available options. Let's click on the internal load-bearing walls single leaf thumbnail. It follows a very similar format to the external walls thumbnail. We can enter the length in here. Click Next. We now have options for the construction type. So again, brick and block, just bricks or just blocks. The course information for the chosen setting is shown, and we can view the dimensions of the brick and block that is to be used. When this is set to our preferences, enter the details. Any double leaf internal load-bearing walls are entered here. Before we click the thumbnail, we can see the current setting for these walls in this picture. Let's click the thumbnail. First we need to select the wall type. There are options for a double wall or trench blocks. Both options work in the same way, but let's click double wall. In the next form, if we haven't done so already on the pricing sheet, we enter the length of the internal double leaf load-bearing walls. We're provided with a pictorial reference. Once entered, click Next. Again, we have the form that enables us to choose the method of construction. So brick and block, just brick, or just block. Simply click on the picture that shows the method that is to be used. The course quantities are shown. The blue text explains exactly how the program's calculating, and we can view, and if required adjust, the dimensions of the brick or block that's going to be used. When done, click Enter Details. The internal load-bearing walls for our ground floor are priced. Subbase Depth. The subbase depth is here. The program carries out multiple calculations based on the information that we have entered and does this calculation for us. However, we still have control over the settings and can adjust the defaults if required. We can also view exactly how the program has done this complex bit of number crunching. We'll get to that in a moment. Let's start by clicking this thumbnail picture. This interactive visual reference is fantastic and makes carrying out any fine-tuning so simple. The depth of topsoil is pre-filled. This is the number we entered earlier. If we want, we can adjust the material selection for the facing brick and the floor insulation on the perimeter of the slab by using these drop-downs. We will notice that each element of the picture is labelled. There's a lot of detail, so this makes it instantly clear what's what. We can enter the oversight concrete depth in this red box. By default, insulation is included, but if it's not required, untick the box. We can adjust the insulation material in this drop-down. The thickness of the selected insulation is shown in this box. If we change the insulation material to one that has a different thickness, then the program will pick this up. And as the thickness of the insulation does have an effect on the depth of the subbase, the program will automatically recalculate the subbase based on this alternate insulation thickness. Blinding. This is also included by default, but if it isn't needed, untick the box. If we enter or adjust the measurements in this picture, we can see the subbase depth adjust accordingly. The subbase fill material is here. Use the drop-down to change it if required. If we want to understand exactly how the programme is automatically calculating the Subbase Depth for us, this info icon provides a pictorial reference guide. By default, the Subbase calculates on the premise that the concrete is going to be flush with the DPC. But we do have options that enable us to allow for the concrete being below or above the DPC. This info icon provides assistance on how to do this. But basically, if we want our concrete to be below the DPC, we would enter the height from below DPC in here. If we wanted it to be higher than the DPC, we would enter the height that we wanted it to be above the DPC in this same box, but just make it into a negative number by putting the minus symbol in front of it. Another nice element is this thumbnail picture here. We can get further clarification about how the Subbase calculation has been performed. This picture shows us the sums, and they're based on the actual numbers we've put in. Flooring structure. The NHE Plus provides us with all the options we may need for the flooring structure, these being concrete, timber joists and block and beam. We're able to use any combination of these options, and whatever combination we select, be it just one type or all three, every item we require will be calculated. The job that we are pricing in this movie does have a concrete floor structure on the ground floor, but we're going to look at how the block and beam and timber joist options work. We'll enter the required information for each of these flooring structures independently, so we can see exactly how they're calculated on an individual basis. We'll then remove these options from our quote. The NHE Plus is intuitive, so we'll notice in later sections of this movie that the quote we're producing is based on a concrete floor structure only. Block and beam. To allow for any block and beam in our flooring structure, enter the number of square metres required into the red box or interactive picture. If there is not a concrete flooring structure on the job, we don't need to fill in red boxes for the oversight concrete depth or the concrete slab area. We'll notice that the Subbase depth is automatically calculated and pre-filled. We do not need to delete this number, as none of the Subbase options will be worked out. They're only calculated if we're doing a concrete oversight. The programme knows that block and beam flooring is suspended and that no Subbase is required. Let's enter the area of block and beam. This is 121.04 metres square. This is the total area for the ground floor of our 5-bedroom house. We'll be basing each of our flooring options on this same project. Next, check the cavity width for the walls. We'll now look at the details that relate to this block and beam flooring and see what's been calculated. Excavation is required. It does contain blue boxes, and we will complete the ones we need. We also need to check the information for the walls below DPC. We're skimming over these elements, but they are covered in detail in their own movie section. OK, so here is the block and beam flooring section. The first item is the block and beam. This is calculated on a square metre price to reflect the way that block and beam is purchased. So this cost includes both the blocks and beam. We can use the drop-down list to select a different type of block and beam, or we can add our own block and beam square metre based quotes to the material library. Next we have the slip blocks. This is a really clever feature. Let's look at the available options on the picture. By default, the programme is set on option 2. So the beams are just sitting on the walls and the walls will be built past it. This means there isn't an allowance for slip blocks, and the walls below DPC are being calculated based on the measurements that we entered in the red boxes at the top of the ground floor section. Option 1 allows for the block and beam being built into the wall. When we select this option, the programme will automatically calculate the slip blocks that will be required to fill the gap created when the blocks from the block and beam are on the wall. When we select option 1, the NHE Plus will automatically adjust the walls below DPC to allow for this. The text here explains this. We'll also notice this yellow box. If the block and beam is being built into the walls, then we may want to make a deduction to the floor areas, as the actual floor area will be less than the block and beam area that we've entered. If a deduction is entered into this yellow box, it won't have an effect on the area of block and beam flooring, but it will reduce the following items: the subfloor or weed membrane concrete, weed membrane polythene, the area of soils to be removed, any floor finishes such as floor screed, floating or timber floor, and any insulation for these floors. We can view the details of the reduction in this info icon. Before we switch to option 1, let's look at the current calculations for the walls below DPC, based on slip blocks not being allowed. Now let's go back and select option 1. Enter our deduction in the yellow box. See, the slip blocks we require have been calculated. And if we look at the walls below DPC, we can see these have instantly adjusted to allow for this. We can change the length of the slip block in the picture and change the type of slip block by using the drop-down menu. The sand for grouting is calculated. There are options to adjust the thickness of the grouting. We also have the option to specify the way in which the sand is ordered. We can change the mix for the cement by using the drop-down menu. Enter the quantity of any air vents here. We'll put in 18. We'll require a crane for 1 day. The cutter, cutting discs and cement mixer are automatically calculated for us. The concrete underfloor void section is here. This is also relevant to the pricing up of block and beam. This can also be referred to as the subfloor or weed membrane. This is automatically worked out when we enter the block and beam area. Due to the area of this block and beam, we will be using a ready mix. But if, for example, we were using block and beam on a small extension and needed to mix by hand, we can quickly change this to a manual mix like this. The concrete or weed membrane is automatically calculated. We can click on the red question mark and view the thickness. By default, it's set at 50 mm. To change it, just type the thickness we require into the yellow box. If for any reason we do not want to allow for this, tick the box here, the costs will be removed. Polythene's worked out. Again, if we don't need it, tick the box. Enter the number of rolls of jointing tape required, if any, or put in 2. The block and beam is priced. We'll now remove the block and beam details and look at the timber joist floor structure option. Timber joists. To allow for a timber joist in our flooring structure, we use the timber joist section located here. If we're only doing a timber joist floor, we just complete these red and yellow boxes at the top. If there isn't a concrete flooring structure on the job, we do not need to fill in red boxes for the oversight concrete depth or the concrete slab area. If there isn't any block and beam, we do not fill in this red box. The Subbase Depth is automatically calculated and pre-filled. We don't need to delete this, as none of the Subbase options will be worked out. They're only calculated if we're doing a concrete oversight. The programme knows that a timber joist is suspended and that no subbase is required. It will also automatically calculate the concrete under void or subfloor for us further down the ground floor section. Let's tick the box to open the timber joists section. Remember, this section is for ground floor timber joists only. Don't enter any details of any upper floor joists in here. These are entered later in the pricing sheet. We're going to price this section using our 5-bedroom house plans. Using the ground floor plan, we're going to break the timber joists flooring up into 5 sections, or bays, like in the picture. We just enter the width of each bay and length of the joist. If we need any clarification on what's meant by this, click the blue info icons and we're provided with a pictorial reference. We can adjust the names of each section if required, and enter the number of any doubles that may be needed in each bay. We can change the material by using the drop-down menu like this. The centres for each bay can be changed here. We'll notice that as we enter these measurements, we can see how many linear metres of the selected timber we'll need for the bay. But better still, we're also automatically provided with a cutting list. The programme will look at the length of joist and automatically round it up to the nearest length that can be purchased. When we've entered the bays, we can put in the lengths of any trimmers or any other joists that may be required. We can close this section if these aren't needed. The restraint straps have automatically been worked out. The quantity required is shown here. Let's click on the red question mark and view how the programme's calculated this. The programme is set to allow for restraint straps and centre strutting if the span of the bay is greater than 2.4 linear metres. We can adjust this measurement if required. Restraint strap noggins are here. Let's click the question mark. So this is the noggins underneath the restraint straps. We can see how they're being calculated. As it's a yellow box, we can adjust this length if we want. There are lots of options for the centre strutting, and changing it to our preferred choice is really simple. We can use the drop-down menus on the pricing sheet, or click the question mark. The interactive picture provides a visual explanation of the available choices. So herringbone timber, solid noggins, or herringbone steel. Just click on the one we want. We'll click solid noggins. We need to choose the material. We'll select 38 by 150mm treated softwood. Enter it in. The pricing sheet instantly adjusts and we can see the quantity and cost information for our choice. As we have entered doubles, the bolts are worked out. This is based on the bolts being used every 0.6 linear metres, but we can change this if we want. The washers and timber connectors for our bolts are here. We have a blue box for joist hangers, so our judgment is needed. If there are any joists going onto trimmers, just enter the quantity of joist hangers needed in here. Masonry joist hangers for the ends of the joists have been automatically worked out. Quite often on the ground floor, the joists are set on hangers, rather than running into the actual walls. So by default, masonry hangers are allowed. But we can switch this option off by clicking this button if they aren't needed. If we switch this option off, because the joists are being built into the walls, then the masonry joist hangers' costs and quantities will be removed. We'll also need to enter in any deduction that needs to be made to the floor area, as the actual floor area will be less than the joist bays. If a deduction is entered into this yellow box, it won't have an effect on the area of joist bays, but it will reduce the following items: the subfloor or weed membrane concrete, weed membrane polythene, the area of soils to be removed, any floor finishes such as floor screed, floating or timber floor, and any insulation for these floors. The plans that we are working from would require us to do a combination of things with our joist hangers and floor area. Let's look at the plan. The joists to the perimeter walls will be sat in joist hangers, but where the internal load-bearing walls are, highlighted red, the joists will be sitting on these walls and so hangers won't be required. Also on our plans, two bays of joists cross over each other. We can see this in this picture. This will mean that a reduction to the actual floor area is needed. Let's look at Section 1 and Section 3. They cross over each other. Section 1 has 20 joists and Section 3 has 21 joists. As these are sitting on the internal wall, a deduction of 41 joist hangers needs to be made. Section 5 crosses over with a part of Section 3. Section 5 has 8 joists, and the same quantity of hangers can be deducted from Section 3. So we add 16 to 41, giving us a total of 57 joist hangers that need to be deducted. So we just deduct this from the quantity automatically calculated and enter the new number into the masonry joist hanger box. We also need to make a small deduction to the floor area, where the joists cross over and are sat on the internal load-bearing walls. This is 1.08 metres square. Let's enter that in. As the above example shows, the NHE Plus enables us to really drill into the detail for our joist flooring structure and achieve complete accuracy. Going through this process, though, is of course optional. It may be that if it's a small job, this degree of accuracy isn't necessary, as the differentials may be negligible and accounted for as wastage. But nevertheless, we have the options available if we want to use them. The buttons for setting out, as well as the fixings, are worked out. Nothing's forgotten. We can, if we wish, drill into the details and adjust the settings for these fixings by clicking on the red question marks. We'll now look at the other details that relate to this timber joist flooring and see what's being calculated. Excavation is required. It does contain blue boxes and will complete the ones we need. We also need to check the information for the walls below DPC. We're skimming over these elements, but they're covered in detail in their own movie section. The concrete under floor voids section is here. This can also be referred to as the subfloor or weed membrane. This section is also relevant to the pricing up of a timber joist floor structure, and is automatically worked out when we enter the timber joist area. Due to the size of the area for timber joist flooring, we will be using a ready mix. But if, for example, we were using timber joists on a small extension and need to mix by hand, we can quickly change this to a manual mix like this. The concrete or weed membrane is automatically calculated. we can click on the red question mark and view the thickness. By default, it's set at 50mm. If, for example, we need it to be 100mm, just type this measurement into the yellow box and the calculations will change. If for any reason we do not want to allow for this, tick the box here, the cost will be removed. Polythene is worked out. Again, if we don't need it, tick the box. Enter the number of rolls of jointing tape required, if any. We'll put in 2. The timber joist floor is priced. We will now remove the timber joist details and look at the concrete floor structure option. Concrete oversight. We'll now look at the concrete flooring structure option. We have removed all of the timber joist flooring and block and beam flooring that we entered previously. The quote that we're preparing does have a concrete flooring structure. So once we've entered and checked the details, we will be leaving this option, and the other sections of our pricing sheet will be based on this flooring structure having been allowed. OK, so we saw earlier the subbase is automatically calculated. To finalise the depth and switch the subbase options on, we do need to enter the depth of the concrete oversight. We can do this directly in the red box, or we can enter it in the subbase picture like this. Next, we enter the area of the concrete slab. We click the red question mark and enter it into the picture. Check the cavity width. This is a pre-filled yellow box that we may wish to adjust. OK, we've provided the programme with the information it needs to calculate our concrete oversight. We'll now be taking a detailed look at the excavation of soils, walls below DPC, insulating concrete formwork, and the subbase and concrete slab sections. We can watch this all in one go, or click the Contents button located at the bottom right of this viewer and go to the sections individually. Excavation and disposal of soils. We have blue boxes in this section that will require our judgment. We're able to allow for any manual excavation. We don't require it on this job, but we just enter the number of days to be allowed for this task and the quantity of hours. For example, if we wanted to use 2 men for 1 day, we'd enter 1 in the days box and adjust the hours to 16 to allow for the 2 men. I'll just remove this detail. The type of excavator is here. We can adjust this by using the drop-down menu. We'll need this for 1 day to strip away the soils. So enter 1. The number of hours is pre-filled automatically in this yellow box. We can adjust this if we want. We don't require a dumper. But if we did, again, we'd enter the number of days we'd need it for into the blue box and check the pre-filled yellow hours box. Disposal of soils is dealt with here. By default, it's set for them to be taken away, but if they're staying on site, we just untick this box. The picture shows us the hours per cubic metre allowed for each available waste disposal method. The boxes are pre-filled, but they're yellow, so we can adjust them if we want. They do vary, as the programme knows that removing the soils via a 1-yard bag will be a much slower process than getting in a tipper lorry, for example. We can view how the expansion rate has been calculated by clicking here. We can adjust the percentage. We may want to reduce this if we're working on a site with sandy soils, or perhaps increase it if we're working on a site that has heavier boulder clay. If, for example, we adjust this to 25%, we can see the new totals instantly in this picture. We'll just change it back. This is our current method of waste disposal, a 6-yard skip. Let's adjust it to a 17.5-tonne tipper lorry. We can see the quantity required and the number of hours it will take to dispose of these soils. We can adjust these hours. Let's click on the Disposal of Soils question mark. We'll change the tipper lorry time to 0.15. Instantly, our hours adjust. Walls below DPC. Let's look at the Walls below DPC section in detail. This is where all our bricks and blocks for the ground floor walls that we've selected are shown. Our external walls are a brick and block double wall construction. Our single and double internal load-bearing walls are also a brick and block construction. We can see the allowance for our bricks and blocks. It's shown on a number basis, so we can see the actual number of bricks and blocks that we'll need. If we prefer, we can change this to square metres by clicking this thumbnail here. Let's change it. It's really straightforward. Just click the picture, instantly everything adjusts. OK, so we have the bricks to DPC. These are the regrades, or if required we can change them to engineering bricks. We can adjust the material that's to be used here in the drop-down menu. It's important to note that this number doesn't include the actual facework. So any material we select for the bricks to DPC needs to take this into account. Like the actual running order of a job, the facework is dealt with and allowed for later in the pricing sheet, in the walls section, after all the concreting and everything's done. For further clarification, click the blue question mark and view the pictorial reference. We didn't select trench blocks for our walls below DPC construction, but if we had, they would have been automatically worked out, and the details would be here. We have the option to change our mind if we want. We just tick the box. The trench blocks are calculated, and the blocks are instantly reduced to allow for this. Also, the aggregates and concrete for the cavity fill is removed, as it's no longer required. If we tick this and nothing is calculated, this will be because it's not possible to fit a row of trench blocks in. This could be due to the wall height being set too low, or perhaps the height of the facing bricks is too high. In this case, we just go back to the top of the ground floor section and adjust the height settings in the external walls thumbnail picture. We don't want trench blocks, so I will just untick these to remove the costs. Next we have the dry silo. As we didn't select this in our site setup, the programme knows that we don't require one, so nothing's been worked out. If at this point we decided we did want one, we just need to go back to the site setup section of the pricing sheet and add one in. This would then automatically calculate. Our sand has been worked out. We can view how this has been done by clicking on the red question mark. We also have control over how it's ordered. At the moment, the programme is rounding this up to the nearest half tonne. But if, for example, we always buy in sand by the tonne, we can change this in a yellow box. The cement is calculated. We have options for the mix. We just use this drop-down menu. By default, it's a 6-in-1, but if we change it to, for example, a 3-in-1, we can see the quantity of cement required instantly recalculates. Let's just change this back. The plasticizer for the mortar is here. Again, we can view the criteria for this calculation and change it if we want. If we're using wall ties in the ground, we can select this option. Just tick the box. Clicking the question mark shows us how this is being calculated, and we can change the spacing if we wish. Concrete lintels is a blue box, so our judgment is needed. If we have any underground pipes passing through the ground floor, we can allow for the lintels here. We have 8 on this job. Aggregates for the cavity fill are here. As we haven't chosen a trench block, we have ballast. If we click this question mark, we can see the dimensions of our cavity. This is the cement for the cavity fill. We can adjust the mix if we want. Again, just use the drop-down. A cement mixer has been allowed, and all of the hire charges, including delivery and collection, have been worked out. Insulating concrete formwork. As we saw when entering in our choices for the wall structure, we do have options for insulating concrete formwork. This isn't required on this job, but let's take a look at how it works. Tick the box to switch it on. We have the option for single wall or ICF with an outer leaf. Let's click that one. The bricks and blocks automatically adjust to allow for this, so the quantities in here are for the outer leaf and the internal load-bearing walls. If we had clicked the single ICF option, on this example, because we have internal load-bearing walls, the bricks and blocks required for these would remain. Let's look at the ICF items that are instantly worked out. The corner blocks are here. We can click the blue question mark for a visual reference. The vertical and horizontal rebars are worked out. We can view how these have been calculated by clicking the red question marks. In here we can adjust the settings, so we can change the overlap, centres and quantity of bars per row for the vertical. In the horizontal rebar picture, we can change the centres, quantity of bars per row and the height of the first bar. The ties and end stops for our corner bricks are worked out too. There is the option to switch off any of the costs and remove them from our quote. Just click the Yes button. The blocks are here. And here's the concrete for the fill. There is the option to adjust the filling time. Click the red question mark. The setting for the amount of time allowed to fill per cubic metre is here. Just change it if required. We're not using ICF in our ground floor, so I'll switch this option off. It really is that simple. Subbase and concrete slab. The job that we're pricing does have a concrete flooring structure. We specified this at the top of the ground floor section when we entered the measurements for the oversight depth and area of the slab. The subbase was automatically calculated and was switched on when we entered the oversight and slab area into the red boxes. Let's look at the details. The quantity of subbase fill is here. We can adjust the materials selected if we wish. The excavator has a blue box, so this will require our judgment. We'll need an excavator for a day to help move the subbase around, so we'll enter 1 here. The compactor is another blue box, so estimator's judgment again. We'll allow 1 day and enter in 5 hours. If you viewed the subbase section, you will recall that we allowed for blinding. We can change our mind here if we want. Just untick the box, it will be removed, and the depth of our subbase will automatically adjust. Or, if we want to change the thickness, we can do so in the picture. The membrane for the concrete under the slab, the DPM, is worked out here. We can change the selected material if required. We have the option to enter jointing tape. This is a blue box, so our judgment is needed. We'll enter in 2 rolls and allow half an hour for this. The costs for the concrete slab are calculated for us. By default it's set as ready mix, but if for example we're doing a small extension or porch, we can quickly switch this to manual. Just click on the picture. We've got the floor insulation. This is the main insulation for under the slab. We can remove it by unticking this box if we want. We can also adjust the type of insulation here in the drop-down box. Reinforcement is automatically included. We can remove it by unticking this box. We also have the option to add additional layers. Just click the red question mark. See, if we change this to 2 layers, the costs automatically change. We do only need 1, so we'll just change that back. The spacers and spacer chairs are worked out. Again, we can remove these if they're not required, or we can go into the interactive picture by clicking on the red question mark and view how these are being worked out, and adjust them if required. Adding additional items. All of the common and not so common items and tasks required for the ground floor are within this section. But if we do need to include an item or task that's not listed, we can add it. The Add Extra Row button is here. Next to it we have blue info icons. This provides straightforward instructions about how to use this feature. We don't need any additional items in the ground floor section of this quote. It's important to note that once the Add Extra Row button is clicked, the row that is added can't be removed. So if things change and the item is no longer required, we just need to remove the quantity in hours to ensure that it's not calculating. For this reason, I'll carry this process out in an alternate quote to show us how it works. We are in an alternate quote now. To add an extra row, just click this button. A new row will be generated. This can take a moment. We're then provided with a self-explanatory form. Just work from left to right. Enter the line title. This is the description of the additional item or task that's being added. If it's a material or plant item, we use the drop-down menu to choose which one. Then use the following 2 boxes to drill down to the item that's needed. Then enter the quantity. If it's a labour-related item, we don't need to use these boxes. Enter the hours required for the item, or if it's a labour-related addition, just go straight to the hours box. Select the tradesperson who will be carrying out this task, click Add Details, and the information will be transferred to the bottom of the pricing sheet. OK, I'll go back to the quote that we're working on. Totals. The totals for the ground floor section that we've priced are here. We can see the individual costs for the plant, materials and labour. The total number of hours required for this section of works, and the overall cost for this section of works. All totals on the pricing sheet are cost. No markups or VAT are included.